Hey there. So you want to learn how to program, and you've never programmed before in your entire life. You might not even know really what programming is. If you follow us through these tutorials, you'll gain a new understanding that you've never had before. That is the ability to create whenever you want, whatever you want, and mostly for free. If you're going to build a house, for example, you need to buy lots and lots of materials for each house that you build, and each mistake could cost you lots of money. In the professional world, mistakes in programming can cost money too, but while you're learning, they will only cost you your time. You will learn a tremendous amount from those mistakes. When you write code, you don't always need to buy stuff. A lot of times, programming can be free, except for the cost of a computer, of course. Program doesn't just have to live inside of your computer. I've written programs that live inside beauty shops or that go into machines that build 3D. You may be thinking that you want to build an iPhone app or a website. So in order to program, you first need to pick a programming language for you to speak. You need to learn at least one language. So what is a programming language? Well, depending on the thing that you want to do, you might be better off choosing a specific language. Inside of this machine that you're watching this video on right now, there's gajillions of things happening. Gajillions of things. That's one with a bazillion zeros. Your computer is sending information to your hard drive to write files and display tiny pixels on the screen that do tons and tons of other stuff in there. Even when it's not making any noise at all, it's probably still doing tremendous amounts of stuff. In fact, that's the thing that computers are really, really good at. Doing things over and over and over again. They never get tired. They never say, no, I don't feel like doing that. They're mind-blowingly good at counting to very high numbers. They're really good at remembering large amounts of stuff, like insanely large amounts of stuff. They're good at communicating with other computers very quickly. This series, I'm going to use the Swift programming languages, but I have other series where I do the same exact thing in Python, in JavaScript, and in Ruby. The Swift programming language just came out less than a month ago, so it's a little bit of a dangerous ground because it's constantly changing. Currently, in order to write code for Swift, and in order to make apps for the iPhone and the iPad and the Mac, you need to have a Mac yourself. With other programming languages, you don't need a Mac. You can use Windows. If you want to currently write Swift programming language at this moment, you need to have an Apple developer account, which will cost you $99 for the year. If you want to release apps to the App Store, then you'll need this developer account in order to do that. There's plenty of other languages that you can get started with, and I'll show you how to do those in other videos. And you can do those for free. The good news is that if you learn Swift as your first programming language now, then it's possible that by the time Apple opens up the App Store for iOS 8 Swift apps, you'll be ready to go with your first app with our series for beginners. To me, it's worth it because Swift is a language that, in my opinion, is a lot like a lot of other languages. So even if you learn something else later, you'll be ready because Swift is very flexible. So enough talking. Let's figure out how to get started. You're watching this from scratch or close to scratch. So I'll tell you that all the code you're going to write goes in some sort of plain text files. Always, every single time. When you think of writing plain text files, you're probably thinking of writing a Word document or something like that. But if you want to see what a Word document looks like in plain text, open it up in a plain text editor. Let's do that now. You can get a copy of Atom or Brackets for free. I love free stuff. So you can just go to atom.io and you can download this for Mac. Or you can go to brackets.io and download this for Mac as well. They're both plain text editors. I'll open up Atom. So when you open this up, everything that you type gets saved exactly like how you type it. But here is the script to this beginner programming tutorial, and this is a Word doc. If I open this up with Atom, you'll see what happens. And you can see that when you open this up, it looks completely insane. You'll notice that it doesn't look anything like what we originally stored. That's because when Microsoft stores your files, they have a way of saying that's bold and that's italic and stuff like that. Only Word can open up those type of files because it knows how to read it. Just like those slideshows for those old ViewMasters, those ViewMasters were meant to hold those slideshows only. And just like Word is meant to view this and read this specific type of file, you can try this out with a PNG or a JPEG image also. You'll see that that looks exactly the same as well. What we're going to do is we're going to write in a plain text editor, and something is going to take that code that we write and turn it into something that the machine, your computer, can read. If you don't have Swift yet, let's do that. You just need to download the latest beta of Xcode. Or if you're watching this and Xcode 6 is already out, then you can just go download it from the App Store. At this moment, it's still in beta, so we'll go to developer.apple.com. And then you have to go to your Members Center. Now, I can sign in already because I have a developer account. You'll need to get a developer account, which costs $99 for the year, and then you can download the latest Xcode beta version by going to Dev Center, iOS, and then down here, you'll see Xcode 6 Beta 3. Download that baby and install it and run it. So I'll open up Xcode Beta 3. Look at you, rockstar programmer, making things happen. There's some choices here. You're going to click Get Started with Playground, which is right here. This opens up a plain text editor once you save it. We can call this My First File. This opens up a plain text editor, meaning that the stuff that you save will get saved exactly like you write it. You cannot edit this in Word, so don't even try and do that. The words you write here will tell the computer what to do. You can see there's already some stuff here. We're going to just highlight it all and delete it all. To make things easier for you, when you write certain words, it'll turn them into a certain color, which will make it easier to read for you. This specific editor that you opened is called the Playground. It will run your code automatically for you, so you don't even have to run your code ever. The process that has to happen to take the special words that you write and turn them into something that the machine can read is called compiling. Because the machine cannot directly read the words you write. It can't interpret that. It just can't do that. This language was written for us to be able to speak to the machine in a clear and easy way. We compile this code and turn it into machine language. And you can write the machine language on your own, by yourself, and people used to do that. But now we have a quicker way of doing things. We can use Swift and other languages to write our code that will then turn it into machine language that a computer can read. You'll never have to look at this machine language ever. Each word that we type does something different. Some of the words are for naming things to use later, like how you write your name on a cup when you go to a party so that you know which cup is yours, or how they give you a sticker with your name on it that says, "Hello, my name is," and people can identify you that way. We could say that the different things that we write can do different types of things. And I used the hand quotes, but you can't see them for the word types. One of the easiest things you can do is to store your stuff on the computer. It's even faster than saving a Word doc, and it takes up much, much less space. Let's save the number 5 for later use. And this number 5, if it was a cup at a party, you would write something on it to identify it. So let's give this 5 a name to identify it, and let's call it the word 5. Before we do this, we deleted everything on the screen, so make sure you have a blank screen here. And this is going to be the first code you ever write. So you could write 5 equals 5. So the word 5 equals 5. That says that when we call the word 5, this, later, it'll tell us that it's equal to 5. This isn't going to work because this is not how you store things in Swift. We need one more thing. We need to tell it that we plan on storing this, so we'll just add one more word to this and then we'll be good to go. We need to use the word var. Var stands for variable. A variable means I want to store this. So we'll write var here. And you'll notice that the red exclamation point went away, which means that our error, our bug, was solved. Congratulations. You just wrote your first line of code, and you just solved your first bug. You just stored something. So how do you know that you stored something? Well, let's try and get it back. All we have to do is go down here, and it doesn't matter how many lines you do. You can just write 5. And you'll see that you get the number 5 back. It actually returned what you stored. So you stored 5 in this variable, and it returned that back. I bet if you change what 5 equals to, then it'll change it down here on line 3 also. The way that you know this is line 3 is because over here there's line numbers. So let's change this from 5 to 6. You can see that now when we try and get 5, it returns 6. They both changed. This area to the right here tells you what's happening. In this case, we wrote 5, so it's going into the computer and it's going to see if it can find that thing that you stored. It looks like it found it, so it's going to give you back that thing that you stored. So now this 5 no longer makes sense. The word 5 here doesn't make sense anymore because we now store 6 in it. Maybe we can give the name of this variable, maybe we can make it a little more variable. Maybe we can make it so that it stores a number that's not just 5s. Let's rename this to the word number. And we save it by holding Command and pressing S. Or you can go to File, Save. So now we get an error down here on line 3. That's because the computer's searching for the thing that you labeled with 5, and as it turns out, this time you didn't save anything with the word 5, because 5 no longer exists. It's now called number. You renamed it. Each time that you save this program, it starts from the beginning of the program as if you've never ever run it before. As far as this program is concerned, it's never been run before, even though you did run it before, so it's going to start from the beginning. So if we print our number 6, we need to write out our new variable name. So here it says 5. Let's change it to the word number. And now we got rid of our error. Nice job. Now we get back 6 here. So this is all well and good, but it doesn't really do much. 6 is a number. So when I was in first grade, I learned that you can add numbers together. So let's go back and add a couple extra lines at the top. And let's write 6 plus 6. And over here on the right, you can see that it returns 12. So you can see that it made 12. Now what about our number variable? Well, that's storing that our number 6 is in the variable number. We can think of it as being the number 6 right now. That number is the number 6. We should be able to use it just like our number 6 above. Let's try it out. We can go down here and say number plus 3. It turns out that that works because 6 plus 3 is equal to 9. So now we get 9 back over here. You're making progress. We just stored a number and used it later to add a different number. Does that make sense to you? I think it should. I want to show you something really cool. Computers don't just store stuff. They of course have to make decisions. Like if you wrote a computer program that's inside of an airplane and the airplane lands itself, it has to decide if it's going to keep lowering the airplane or bringing it back up. I want to show you how you can ask the computer a question and it's going to give you an answer. There's two things you can write that look very similar but act very differently. Look above. You use the equal sign to make something equal to something else. You said take the number, the variable number, and assign it to a 6. So you use that little equal sign here, one little equal sign to assign something to something else. You can't say 6 is equal to 3. You can't assign a number to a different number because 6 doesn't equal 3. 6 only equals 6. The world would explode if that worked, and that's exactly why it doesn't work. So don't try and do that. But you can ask the computer if 6 does equal 3. Now you know the answer to that. Does 6 equal 3? No, it doesn't. All you have to do is add one more equal sign here, and it's going to test. It's going to say, does 6 equal 3? When you do this, you're saying to the computer, does 6 equal 3? If you just take away the one equal sign, you're trying to assign 6 equals to 3. We didn't need the computer to figure out that 6 doesn't equals 3, but the computer knew the answer anyway. You're now able to ask the computer a question and get an answer. So the big difference between the one equal sign and the double equal sign is that you use the double equal sign to ask the computer if one thing is equal to the next, where you use the one equal sign to assign something to something else. So we use the one equal sign to assign number equal to 6. Let's try and ask another question. Hey computer, is number equal to 6? We can say number equal 6. And it will say over here that that's true. So of course it is. Look up at the top. The number is assigned to 6. right here, var number is equal to 6. Then below, we ask the computer if number is equal to 6. Now what happens if we change that number that we assigned it to? So instead of equaling to 6, we change it to 7. Now number is not equal to 6, and we get a false here. Nice job. You're rocking it out. You're going to be working at NASA in no time. Oh, you get car sick on spaceships? That's okay. You can stay inside all day and program. Our only problem is that we have only been working with numbers up to this point. So if you wanted to make a game and write something to the screen like game over, you would be out of luck. You could write the numbers 3, 2, 1 on the screen, which could mean game over, but no, we won't do that. So we could save words and characters. How do we do that? Well, let's see what happens if we change our example and rewrite it. So we remember that we stored something by writing var. We'll write var word equals hello. So we want to say that our variable word is equal to hello. You can see that that didn't work. Why? Because when you just write a word like that, hello, you're telling the computer about a variable, just like we did with the word number above. You're telling computer, look for the variable hello. We need a way to say that this isn't a variable, but it's an actual word or a string. That's what we call text in a program. We call it a string. We need a way to say that this is going to be a string. To do that, we just use the double quote marks. So we put a quote around each side of this. So we put quote marks around this, and suddenly there is no error. Now we've stored a couple of things in memory inside the computer. We have the number 7 stored above, which you named it to number, and we have the word hello as a string stored in the name hello. What happens if you add two strings together? You can add 6 and 7, but you can't add hello and world. Or can you? Let's try it. So we're going to write down here word plus world. It worked. It concatenated the two strings together. It totally worked. So now we have hello world with no space. Can we add a space to this so that it makes sense? Well, we have two options if we want to do this. We could just add a space right here, and that's going to print back hello space world, or we can concatenate even another string onto this. We could add a string with a blank space in the middle, and that's going to make it hello world. Nice job. I want to show you one more thing before I let you recover from this whirlwind of information. The word variable means that something is variable, that it can be changed. Notice how we store a word in memory. We stored the word hello. That can be changed because we used a variable. A variable means that something can be changed, just like in the real world. So now we can say word is equal to goodbye. Now you can see down here that this is printing out goodbye world because we stored word as a variable that can be changed. It indicates that this place in memory that we stored is changeable. What if we didn't want this to be changeable? What if we wanted it to be stored in an area in memory that couldn't be changed? If they tried to change it, maybe it should throw an error. Like if we wanted to store pi. So if we wrote var pi is equal to 3.1415926, we don't want somebody to be able to change that because that wouldn't make sense. But right now we can change it. We can say pi is equal to 42. And it doesn't throw an error. The world should explode at this point. If you want to change this from a variable to something that can't be changed, that's called a constant. We just changed the word var to the word let. And now we're talking about something that cannot be changed. And look, it threw an error. It said that you cannot assign it because it is a constant. That's all I'm going to talk about for now. We'll talk more the next time, and you're going to see how to do lots more stuff. Thanks a lot.